Simplifying algebraic fractions is not dissimilar from simplifying normal fractions. We just look to cancel the common factors. Sometimes we have to tease them out and figure out what they are. So we don't want to, if we're canceling and we look at something like this, that 2x plus 4 over 2, the 2 applies to everything there. So we could cancel both of these, but let's make it safe. Let's factor out the common factor of 2x plus 4 to be 2. And then we can cancel out the 2's and we're left with just x plus 2. So to multiply algebraic fractions, it's just normal. Factorize where possible. Cancel where possible, always a good idea. And then just go ahead and do as you normally do, multiply the numerators and denominators. Dividing algebraic fractions is the same deal. We just want to use keep, change, flip. So multiply rather than divide by the reciprocal. So the reciprocal is that fraction flipped upside down. Let's look at some examples. Simplify this one. The first thing we're going to do here is recognize that we've got x minus 4 divide x minus 4. So anything divided by itself is 1, so that's effectively gone burger. Then 3 and 6 are common factors, so 3 divided 3 is 1, and 6 divided 3 is 2. So that leaves us with the final answer of, what's left? X plus 2 over 2. And you're tempted to try and cancel out that 2, but remember x plus 2 is as if it's still in brackets. So that 2 applies to everything, so we're done. This one we want to factor out some stuff because we can't really cancel in this configuration. So if we look and see what we have in common, if I rewrite it like a good person, I've got 20 minus 5x. So I reckon you can see a common factor in there in the numbers. We don't have x as a common factor. So let's factor out 5. Leaving us 4, because 5 times 4 is 20. And we'll keep our minus sign there because that works. And that's just x, isn't it? Yeah. So let's use 2 on the bottom. So 2 comes out of 8, leaving 4. And then, oh my goodness, look what just happened. So we found a common factor of 4 minus x. We can now take that out of the picture because 4 minus x divided by 4 minus x is 1. And that just leaves us with 5 over 2, and we are done. Now for this one, I reckon you can see it coming. We've got the difference of perfect squares up there, and then we've got x plus 2 down there. So the difference of perfect squares is going to tell me that the square root of this one plus the square root of that one times, same, but minus. And we're going to put that over x plus 2. I don't really need the brackets, but I'm in a good mood. So x plus 2, divide x plus 2 is 1. So that leaves us with no longer brackets needed, of course, x minus 2. Now when we're looking to solve these expressions, then multiplying, we could just multiply our way across and then cancel, but let's cancel all we can, remembering that we can cancel this way, or we can cancel diagonally either way, but we cannot cancel this way. We cannot cancel horizontally. So let's look at top to bottom. We've got, because remember, when we multiply these are all going to end up being on top of the same vinculum line anyway. So I kill x plus 2 because x plus 2 divided x plus 2 is 1. X minus 1 is 1. And then we've got some numbers on the top. So what if we did, I think the only thing we can do is 9 and 3, because we divide 3 by 3, we get 1, 9 by 3, we get 3. And so all of that great malarkey just leaves us with something very simple. Yep, only the number 4 is on top. And then we've got 3 times x minus 7, and there's no further we can go with that one. For this one, we are dividing. So we're going to keep the first one. We're going to change the sign, and we're going to put the bottom on the top. Let's put them in brackets for funsies. And we're going to put top on the bottom. So we have the reciprocal now. So now just remember we keep, we change, we flip, just the same as any dividing fractions. And so what can we cancel away? X plus 7, x plus 7, x plus 4, x plus 4. So on the top, that leaves us x minus 3 over, this is 3x, no? Yeah, 3x. There you go. So a closer look at this one says I've got the difference of perfect squares over what happens to be a perfect square. And then I've got, it looks like there's something I can factor out there. And then I've got this. So I'm going to have to factorize this puppy. And so we're looking for something that adds up to -1 because we have negative x, and that multiplies to -2. So the difference in perfect squares is easy peasy. Square root plus square root times square root minus square root of these two numbers. And they are going to be over 25. And that's all going to be multiplied by, let's factor out the 5, leaving us with x plus 1. That looks right. That feels right. And then this one. So if I'm looking for a number that adds up to -1 and multiplies to -2, I'm going to end up with x by itself, unsquared, minus 2, the order doesn't matter, and x plus 1, because they will add together to make -1, which is our middle bit, and they will multiply together to make -2. So now we can start having a field day. We can start kicking off things diagonally. Bye-bye, bye-bye. Top to bottom, bye-bye, bye-bye. And then 5 divide 5 is 1. 25 divide 5 is 5. So that leaves us with x plus 2 on the top over 5. That's it.